In the summer of 2023, NASA nearly lost its oldest working spacecraft because of a single wrong command. For 2 full weeks, nobody on Earth knew whether humanity's most distant machine was still alive. Voyager 2, sitting more than 12 billion miles from home, had gone completely silent. The fix engineers eventually tried had never been attempted at that kind of distance before. It meant shouting into empty space using the most powerful transmitter humanity has ever built and simply hoping a 46-year-old spacecraft was still listening on the other end. Everything that happened to Voyager 2, both that summer and in the years since, turns out to be a stranger and more compelling story than most people realize, and none of it needs any exaggeration to feel remarkable. Here is what actually took place out there, what is happening to this spacecraft right now, and how much longer humanity's long-running conversation with deep space actually has left. Voyager 2 launched in August of 1977, technically weeks before its twin, Voyager 1, even though Voyager 1 eventually took a faster, more direct path out of the solar system and overtook it. Voyager 2 chose the scenic route instead, and that single decision made it the only spacecraft in history to fly past all 4 giant planets in our solar system, Jupiter, Saturn, Uranus, and Neptune. That flight path only worked because of a rare planetary alignment that occurs roughly once every 175 years, allowing one spacecraft to use each planet's gravity to sling itself toward the next, rather than relying purely on its own limited fuel. Miss that launch window, and the mission, as it actually unfolded, simply would not have been possible. Along the way, Voyager 2 delivered some of the most important planetary discoveries of the 20th century. It spotted active volcanoes erupting on Jupiter's moon Io, geysers firing off Neptune's moon Triton, and the strange sideways tilt of Uranus along with its unusual magnetic field. It captured close-up images of Uranus and Neptune that no other spacecraft has matched since, simply because nothing else has ever been sent to either planet again. Both Voyager spacecraft also carry something far more symbolic than any scientific instrument, a gold-plated record holding sounds, images, music, and greetings from Earth, sealed inside a protective case engraved with instructions for how to play it, in case anything out there ever finds it. The team behind that record, led by astronomer Carl Sagan, spent months debating exactly what should represent humanity to any future discoverer, eventually settling on natural sounds, greetings, recorded in dozens of languages, and a carefully chosen collection of music, meant to say something honest about life on Earth, without pretending to speak for everyone. By the time the original planetary tour wrapped up in the late 1980s, both spacecraft kept traveling, eventually crossing the heliopause, the boundary where the sun's influence gives way to true interstellar space. Voyager 1 crossed that line in 2012, and Voyager 2 followed in 2018, becoming only the second human-made object ever to leave the bubble our sun carves out of the galaxy. Both spacecraft are still out there right now, still transmitting, still technically part of an active NASA. The mission nearly 5 decades after launch, something nobody on the original engineering team expected when the mission was designed to last only about 5 years. Every extra year since then has essentially been bonus science nobody originally planned for, gathered by heart, were never built with anything close to this kind of lifespan in mind. Engineers have even found creative ways to squeeze out a little extra runway, including tapping into a small reserve of backup power, originally set aside purely as a safety buffer for spacecraft's voltage regulation system, a mechanism designed to protect the remaining instruments in case of a sudden and potentially damaging voltage swing. Rather than continuing to hold that reserve untouched indefinitely, the mission team made a deliberate decision a few years back to start actively spending that safety margin now, in exchange for a few more years of active science later, essentially betting that the benefit of continued operation outweighs the small added risk of running without that particular backstop. It's the kind of trade-off that only makes sense on a mission this far along, where every additional instrument kept alive for even 1 more year represents genuinely irreplaceable data that nothing else in existence is currently positioned to collect. If everything continues roughly according to plan, NASA A current projection is that both Voyager spacecraft should be able to keep at least one working science instrument running into the early 2030s, more than half a century after launch, before power finally drops too low to keep anything meaningful operating at all. As of the most recent mission updates in 2026, both spacecraft are still alive, still transmitting, and still remarkably doing real science from a region of space no other human-built object has ever reached, sending signals that now take more than a full day to arrive back on Earth given the distance involved. Even after every science instrument eventually goes silent, engineers expect the spacecraft could technically continue transmitting basic engineering telemetry a little while longer, a faint signal confirming the machine is still alive and, in some limited sense, still there, right up until the power finally drops below the threshold needed to run anything at all. There is something genuinely worth sitting within just how fragile all of this actually is, without needing to invent anything extra to make the story feel significant. This is a machine built with 1970s technology, running on computers with a small fraction of the processing power of a modern calculator, powered by a source that has been quietly fading since, before most of the people currently operating it were even born, sitting further from Earth than any other human-made object in history, completely beyond any possibility of physical repair. A 2-degree antenna error, something you could accidentally cause by bumping a tripod, nearly ended 50 years of continuous operation in a matter of weeks. And yet it didn't end. Engineers found a way to shout across 12 billion miles of empty space and got an answer back. Think about what that actually required. Holding institutional knowledge about a spacecraft's exact hardware quirks across nearly 5 decades, keeping ground station equipment from the 1970s still compatible with modern control systems, and trusting that a command sent at the absolute limit of available transmitter power would somehow reach a target moving further away with every passing second. Voyager 2 isn't sending back some mysterious new signal humanity cannot explain, and nothing about its recent behavior suggests any kind of external interference or unexplained intelligence responding to it. What it is doing, when you actually look closely at the real engineering involved, is arguably just as remarkable. It is still working. It has been continuously operating for nearly 50 years, using power that decays a little more every single year with no way to ever replace it, carrying humanity's actual greeting to the rest of the universe on a golden record bolted to its side, and it's still, right now, sending back real information about a region of space we have never explored with anything else. NASA's own engineers have openly said that every single day these spacecraft manage to keep operating is essentially a bonus nobody fully expected to get, and that any given transmission could in principle turn out to be one of the last. That is not a manufactured mystery. That is simply the honest, ongoing reality of trying to keep a 50-year-old machine alive at the very edge of what our species has ever managed to reach. The mission itself is entering genuinely uncharted territory in a very literal sense, not just scientifically, but organizationally. Ed Stone, who served as the Voyager program's chief scientist for decades and oversaw the mission through every major planetary flyby from Jupiter all the way out to Neptune, stepped back from that role a few years ago after devoting more than half his life to this single project, a length of institutional memory that is genuinely difficult to replace on a mission where the people who originally built the hardware retired long ago, and where the original engineering drawings sometimes exist only on paper in archives rather than in any searchable digital format. Susan Dodd, the current Voyager project manager at JPL, has been candid in public statements about just how deliberately the team is now rationing what remains, describing the ongoing instrument shutdowns as the price of keeping the spacecraft alive as long as possible, rather than accepting an earlier, more abrupt end to the mission. Every decision about which system to switch off next carries real weight, because once an instrument goes dark, there's no scenario in which it ever comes back on again, and every choice the team makes now is effectively permanent, decided years or even decades before the actual power runs out completely. There's also something quietly poetic about what happens after the instruments finally go silent for good. Even once every last piece of active science equipment has been switched off, and Voyager 2 can no longer send back any usable data at all, the spacecraft itself doesn't simply vanish or stop existing. It keeps moving, having already left the sun's protective bubble behind years ago. It will simply continue drifting outward through the emptiness of interstellar space indefinitely, carrying that golden record along with it for what could effectively be an unimaginably long stretch of cosmic time. Since there's essentially nothing out there to slow it down, damage it, or wear it away the way weather and erosion would on Earth, scientists estimate that the record itself, engineered specifically to survive the harsh conditions of deep space, could plausibly remain readable for hundreds of millions of years, long after the sun itself will have changed and long after anything resembling human civilization as it exists today could possibly still be around to remember having sent it. It's worth pausing on exactly what Voyager 2 has actually been teaching scientists since it crossed into interstellar space, because the region itself turned out to be stranger than anyone fully expected before either spacecraft got there. Researchers had assumed the boundary between the heliosphere and true interstellar space would be a relatively gradual transition, plasma density and magnetic field strength shifting slowly over some distance. Instead, both Voyagers detected a surprisingly sharp edge, more like crossing a real boundary than drifting through a gradual fade, with plasma density jumping abruptly the moment each spacecraft actually crossed over. Voyager 2 also carried a working plasma instrument at the exact moment it made that crossing in 2018, something Voyager 1 didn't have available when it crossed 6 years earlier, giving scientists a far more detailed picture of what that transition actually looks like in real time, rather than having to reconstruct it after the fact from indirect measurements. That single difference between the two spacecraft, one still having a functioning plasma instrument at exactly the right moment and one not, turned out to matter enormously for how much we now understand about where our solar system actually ends and the wider galaxy genuinely begins. Beyond the heliopause crossing itself, Voyager 2 instruments have continued sending back genuinely puzzling readings about interstellar space that researchers are still working through. Magnetic field measurements from out there have shown patterns that don't perfectly match what earlier theoretical models predicted, hinting that the true structure of the local interstellar medium, the thin cloud of gas and dust the sun is currently passing through, is more complicated and less uniform than scientists assumed before actually having a spacecraft physically sitting inside it to check. None of that ambiguity requires any exotic explanation. It simply reflects the plain fact that nobody had ever collected real, direct measurements from this exact region of space before, and reality has a habit of turning out more complicated than any model built entirely from a comfortable distance back on Earth. What makes this story worth telling right now, in 2026, is that we're likely watching the final stretch of an achievement that will probably never be repeated in quite the same way. Future spacecraft will eventually travel farther, carry better instruments, and send back sharper data, but they won't be Voyager 2. They won't carry the specific golden record, assembled by a team led by Carl Sagan in the 1970s. They won't have flown past all 4 giant planets on a single trajectory that will likely never be repeated, given how rarely the outer planets align the way they did during that launch window. And they won't have already spent close to half a century quietly proving that a machine built before most of its current operators were born can still teach us something new about the universe. Every single day it manages to stay switched on. Every engineer currently working on the Voyager team knows they're managing the tail end of something that began before they were hired, and in many cases before they were even born, inheriting decades of careful, painstaking decisions made by people who could never have known exactly how long their work would ultimately need to last. Somewhere out past the edge of the solar system right now, moving through space at roughly 10 miles every second, completely alone, running on a power supply with a hard and permanent expiration date, Voyager 2 is still listening for our commands and still calling back. However many years it has left, that alone remains one of the most quietly extraordinary things humanity has ever built. Think about the scale of what this represents. A machine assembled with technology that predates the personal computer, carrying a physical record of human existence, sailing through a region of space where sunlight itself is little more than a distant memory, and still, somehow, checking in with the people who sent it there nearly 5 decades ago. No other project humanity has ever undertaken has managed to stretch this far, for this long, on hardware this old, and still deliver genuinely new science with every passing year. If this story gave you a new appreciation for what Voyager 2 has quietly accomplished, and what it's still accomplishing right now, hit subscribe, because there are more stories like this one waiting to be told, the kind of history that doesn't need any exaggeration to be worth your attention. Drop a comment below and let me know what part of this journey surprised you the most, whether it's the 2-degree antenna error that nearly ended everything,